and speed is dSdt. Okay, so that's the two big takeaways from this. So if you differentiate displacement, you get to velocity. Differentiate velocity, you get to acceleration. And then to get it backwards, you integrate. So I know we've done a couple of questions on this before the break, but might be a good place just to start there and do one or two examples. Okay, that sound all right?
Miss, what chapter is this again? Like, what's the name of the chapter?
Oh, applications of differentiation.
Okay, thanks.
So basically this chapter and the next chapter is going to be all calculus, and then we have all our calculus done. And then what I'm going to do is go back to geometry, because that's a bit of paper 2, and statistics, which gives us, so that's a big chunk of paper 2 and paper 1 done at that stage. And then we'll just pick up on all the other little bits after that. Let me see. Sorry, I'm just going to pull up the screen. So actually, we had done the displacement velocity acceleration. We'd finished 3.3 and we'd gone on to 3.4. But Nohar, do you want to go through 3.3 again before we start moving on?
Please, yeah.
Okay, so let me just get. Of course, it would be just. Give me a sec. Sorry, things obviously will get smoother. You guys are the guinea pigs for the first lesson. Right, okay. So 3.3 applications of integration. And so the two big things are, if you differentiate, so remember S is for displacement. We don't use D. Apparently it comes from some Italian word. Okay, so S, if you differentiate it, ds dt is equal to V and dv dt is equal to A. So if you differentiate, you go from displacement to velocity to acceleration. And if you integrate acceleration, you get the velocity. Integrate the velocity, you get the displacement. And best way to see that is, I'm just going to write it down here actually. The basic formula here is velocity is equal to ds dt. So that is the rate of change. Hang on, I'll increase the size of the screen. Stop me at any time if you have questions or if you can't see or hear properly. So rate of change of displacement. So how quickly it's changing with respect to, I'm just going to put WRT, with respect to time. Okay, so in other words, if you think of a graph, if you have time is like your X and distance or displacement is like your Y, okay? You might have a straight line graph, okay? If I get the slope of that graph, everybody seen this okay?
Yep.
Yeah.
Yep.
Okay, so just say I'm going from, that's in say 100 seconds, okay? I've gone up to 60 meters per second, okay? And say this is in seconds, okay? And say this is 30 seconds and I'm at 30 meters per second. Okay, let's make that a bit, actually it doesn't really matter. Okay, so your speed, you can say I've gone from 60 to 30. So that's 60 minus 30, okay? And it took me 70 seconds to do it, 100 minus 30. Does that make sense? So that means I'm doing, yeah, that doesn't, actually, sorry, that doesn't make sense at all. Sorry, let's make this. That should be, not that is 30, let's make that 50, okay. So from here to here is your final speed. So call that, if you want to call it S2 and T2, so it's just like X and Y, T2, S2, oh, sorry, I have to sleep after the holidays, and this is T1, S1. That's your X and Y coordinates, okay? So the slope of that graph is S2 minus S1 over T2 minus T1. That makes sense to everybody?
Yep.
And we say when you do S2 minus S1, if you look, you've got 50 meters. This was, sorry, 30 meters per second, 30 meters. 30 meters over 50 seconds, okay? Which is 3 over 5 or 0.6 meters per second, okay? And that is your speed. So the speed is the rate of change of distance with respect to time, and it's also equal to the slope of the graph. Okay, so there's two things. Remember, when you're differentiating, you're getting the rate of change of x with respect to y, and it also means slope. So that's our two things, slope and rate of change. That's what you're doing when you're differentiating, okay? And then you can do the same thing for velocity. If you're looking at the actual speed, so if your speed is changing, and say if we're just going to stick to straight lines for now. So say you go from, again, I'm just going to pick 100 seconds and go up to 50 meters per second. So if this is velocity in meters per second, and this is time in seconds, the slope of that graph is going to be V2. So velocity over time, okay? And that's equal to your acceleration. It's how quick your speed is changing, or your velocity. So we have the slope for a distance time graph or displacement time graph. The slope is equal to ds dt, and that's equal to v, which is your velocity. Okay, so that's the first thing you want to remember. And for a velocity time graph, the slope is your change in velocity divided by your change in time, and that's equal to your acceleration. Okay. Now, we're not going to worry too much about the graphs for now. The reason I brought in the graphs is because we will be going back to those, and because I want you to remember that when you differentiate, you're getting the slope, and it's equal to the rate of change. Okay. And we also know that integration is the opposite of differentiation. Okay. So if you integrate, so if we take our velocity is equal to ds dt, okay, that means that ds is equal to, I'm going to multiply both sides by dt. So that's v dt, okay? If I do an integration of both of those, the integral of ds is just s. Because remember, if you were doing the integral of dx, that's the same as integrating 1 dx. And that's x to the power of 0. So you add 1 to get your new power and multiply by the new, or divide by the new power. Okay, so if you just integrate dx or ds or dt, you just get this letter here. So if I integrate ds, I get a s. Does everybody understand that okay? Any questions? Good?
Yeah.
Okay, and if I integrate velocity with respect to time, that's basically going to give me, so s is equal to the integral of v dt. All right, so that's if you're doing it. So if you're starting with the velocity and you want to get the distance, you integrate it. Okay, and then similarly, if we take this one, dv dt, and I just use delta there, okay, you can say acceleration is equal to dv dt, and if we multiply both sides bt by t, we get the integral of dv is the integral of a dt, and the integral of dv is just v. So if you integrate acceleration, you'll get velocity. Okay, so let's do right, these example 1 out of the book. Okay, so with these, it's going to be straight line, and you're going to be given one of the 3 of these. Once you have one of them, say you have s, you can differentiate it to get v, and then you can differentiate it again to get a. If you're given v, you can differentiate it to get a, and then you can integrate it to get s. And if you're given a, you integrate it to get b, and then you integrate it again to get s. Okay? So once you have one of the 3, you can work out any of the others. So for example, when a body moves in a straight line, at time t, its acceleration is given by a is equal to 6t plus 1. So when you're doing a question, first thing you want to write down is the information you have. So a is equal to 6t plus 1. Write that down. When t is equal to 0, the velocity is 2 meters per second. What this is your initial conditions. Initial means the starting conditions. And that means, what can I say about the time there? What does time equal there? Tells us here. Okay, t is equal to 0. All right. So what that's going to allow you to do is work out your constant of integration. Because remember, every time you integrate, you're going to have some unknown constant. You want to be able to figure it out. Okay, so initial conditions, and they might just call it that in the exam, but t is equal to 0. So I'd write down t is equal to 0, and that means, use a little arrow, v is equal to 2 meters per second, and displacement, remember, is s is equal to 1 meter. Okay, and then they say find v and s. So I've written down the information I have. Next thing is to write down whatever formula I know. And I know that v is equal to the integral of a dt. Okay, that's the formula I'm going to use. So if you're doing an exam question, you make sure you know what your variables are, then write down whatever formula you're going to use. And now we can sub in for a is 6t plus 1 dt. Okay, so when I integrate that, who have we got? Sorry, this. So, Ben, if I integrate 6t, what am I going to get? I think I can hear you, but it's really quiet. Mike. I'm not really hearing you. So, see if you can figure out what's going on with that. Matthew, how's your mic? Can you tell me what that is?
What, 6t plus 1, did you say?
Yeah, if you integrate 6t, what do you get?
It's 6t squared over 2.
Good, yeah. So when we integrate, we add 1 to the power. So the power is 1 plus 1 is 2, and then you divide by the new power. And if I integrate 1, what do I get?
Just t.
Yeah, okay. If there was an x here, I'd get x. If there was a p here, I'd get p. Whatever this letter is, that's what you're integrating with respect to. And we also have our constant of integration, okay? So before we go and find s, we want to work out what the constant of integration is. And we know that when t is 0, v is 2, okay? So v of 0 is equal to 2, where v is a function. So when I put the brackets here, I mean v is a function of t, and when t is 0, v is equal to 2. So v here is 2. So if you like, this is v of t, okay? Because v depends on t. So v of t, when t is 0, I can put 2 in for v. I can put it 0 for t, so I get 0 plus 0 plus c. So that tells me that c is equal to 2. And now I can write down v is equal to 6t squared over 2 is 3t squared plus t plus 2. Okay? And now I can go ahead and work out s, because s is the integral of v dt. So I write down my new formula. Okay, and that's the integral of 3t squared plus t plus 2. And don't forget your dt. Okay, this tells you what letter you're integrating with respect to. So, what else have we got? Harry, can you integrate that for me?
The 3t squared plus t plus 2.
Yeah.
Would it be 3t cubed over 3?
Good.
Plus t squared over 2.
Good.
Plus 2t.
Yeah.
Plus c.
Great. Excellent. Okay. And when we go back to the beginning, we see when t is 0, s is 1. So now we can use that to find this c. And again, I'm just going to write s as a function of t, just to remind us that it depends on t. And I know that s, when t is 0, is equal to 1. So that tells me, put in my s is equal to 1, t is equal to 0. So this is your s value is here. This is your t value. Okay. So t is 0 again, so that's 0 plus 0 plus 0 plus c. So that tells me c is equal to 1. Okay. So s is equal to 3t cubed over 3 is just t cubed plus t squared over 2 plus 2t plus 1. Okay. And then, so now I have my expressions for v and for s and for a. Okay. So once I know what t is, I can find out any one of the three of them. Okay. And the next part of the question just says find the velocity after 4 seconds. So that's basically v of 4. Okay. So go back here to my v. V of 4 just means I'm going to, that's, remember, that's my t value. So I've got 3 times 4 squared plus 4 plus 2. That's 3 16ths, 48 plus 6, just adding the 4 and the 2, which is 54. And that's in meters per second, so don't forget your units, okay? So I think before, what I'm going to do is, fine, we had done questions, let's see, what questions we've done before. I'm trying to give you some different ones. There mightn't do any harm to do the same ones again. So we've done questions 1, 4, 5, 6, 7, 8. So if we do 3 and 4, okay, and try 7 again. So 3, 4, and 7. I'm just going to set that up now. So if you want to get started on those, and then you can ask me if you're stuck on anything. So. This is something we'll actually see again in the next chapter, so it's good to go back over it. We got Aaron's F.
They're still on an island. They're gonna come today.
An island?
Yeah.
What island? Sounds exotic.
Cape Clear.
Not very exotic.
Nope.
Are they there for the whole break? So were they dad?
I think so. I'm not sure.
Everybody doing okay?
Yep.
Yes.
Good. If you want to show me anything you can do, I can turn off the presenting and you can turn on cameras and do it. Another thing, once I get settled in a bit more comfortable, I'm going to try and record the kind of teaching session of the class. So just to make you all aware of that, okay?
Yep.
And then I can upload it to the classroom, and it's there if you do miss a class. I'll have recorded part of it at least. Yeah, kind of trying to get used to this now.
Wait, so if we have acceleration, do we differentiate at the acceleration?
No, integrate. Okay.
Oh, okay.
So. I'm going to actually write it in my book, and if you want to. Because this is one of the few things that isn't actually on your in your log tables. So see here in the book, it has differentiate with respect to time, integrate with respect to time. And they've written the differentiation equations up here. I would write in here, A is equal to the integral of v dt, and B is equal to the integral, that's totally wrong. D is equal to the integral of A dt, and S is equal to the integral of V dt, okay? That's basically what you have to remember. Okay, so what I'm going to do this afternoon, guys, is this assignment here, the algebra revision. I had put up some past papers on that. So we'll go through some of them this afternoon. So if you can be ready to do those later on today, okay? And it would help if you've attempted some, so you can ask me about ones you're stuck on.
Miss, you know those trigonometry ones you gave?
Yeah.
Were they mock? Were some of those mock?
Some of them are mocks, yeah.
All right, grand.
Solutions. I think.
Yeah, no, I saw that at the end.
Yeah. So what I did was put one up that you could just print out if you wanted for the questions, and then another one with solutions on the end.
Yeah.
Yeah, the Study Clicks now has accessibility for mocks and papers, past mocks and past papers, which is good because it gives you kind of more things to work on. So check your answers as you're going along, make sure you're doing it right. Let me know if you're stuck on something. No, I'm making. Okay, lads, you all managing that okay? Be too hard.
Yep.
All right, I'll leave you to it then, and see you this afternoon, and we'll go through some of those algebra past papers. All right, so have a look at them yourselves. If there's any particular ones that you think, okay, I haven't a clue how to do this, we can focus on those. Okay.
Yeah, no problem.
All right, good luck today. I'm sure we'll all be wrecked by the end of it. See you this afternoon then.
Cheers, miss.
Okay, take care.
Thanks, miss.
Thanks, miss.
All right, you're welcome. See you lads.